Electromagnetic waves are a type of wave that can travel through the vacuum of space as well as through various materials. These waves form a continuous spectrum, known as the electromagnetic spectrum, which includes all possible frequencies of electromagnetic radiation. The spectrum is divided into different regions based on wavelength and frequency, ranging from very low-frequency radio waves to high-frequency gamma rays. The major categories in this spectrum include radio waves, microwaves, infrared radiation, visible light, ultraviolet radiation, X-rays, and gamma rays. Despite their differences in wavelength and frequency, all electromagnetic waves travel at the same speed in a vacuum, the speed of light, which is approximately 300,000 km per second. Each type of electromagnetic wave has unique properties and interacts with matter in different ways, which is why they are used in a wide variety of applications, from communication and medical imaging to cooking and astronomy. Refraction is a phenomenon that occurs when a wave, including electromagnetic waves like light, changes direction as it passes from one medium to another. This change in direction is due to a change in the wave's speed when it enters a medium with a different optical density. For example, when light passes from air into water or glass, it slows down because these materials are denser than air. As a result, the light wave bends at the boundary between the two media. The extent of this bending depends on the angle at which the wave enters the new medium and the refractive index of the materials involved. The refractive index is a measure of how much the speed of light is reduced in a particular medium compared to its speed in a vacuum. To understand refraction, consider a beam of light entering a glass block at an angle. As the light wave hits the surface of the glass, the part of the wave that enters the glass first slows down while the rest of the wave, still in the air, continues at its original speed. This difference in speed causes the wavefront to bend, changing the direction of the light. If the light wave enters the glass at a perpendicular angle, it will slow down but continue in the same direction, without bending. However, if the light enters at an angle, it will refract, bending toward the normal and imaginary line perpendicular to the surface at the point of contact. When the light exits the glass and re-enters the air, it speeds up again, bending away from the normal as it does so. The concept of refraction is critical in many fields of science and technology. It explains why objects appear bent or distorted when viewed through water and is the principle behind lenses in glasses, cameras, and telescopes. Lenses use refraction to focus or disperse light, forming images that can be magnified or clarified. For example, a convex lens, which is thicker at the center than at the edges, bends light rays inward to a focal point, making distant objects appear larger and closer. Refraction is also responsible for natural phenomena such as rainbows, where light is refracted, dispersed, and reflected within water droplets in the atmosphere, creating a spectrum of colors. In summary, electromagnetic waves encompass a wide range of frequencies and wavelengths, forming a continuous spectrum that includes everything from radio waves to gamma rays. Refraction occurs when these waves, particularly light, change direction as they pass from one medium to another, due to a change in their speed. This bending of waves is a fundamental concept that explains many optical effects and is crucial in the design of lenses and other optical devices.